Hey, Josie with Queen My Pawn. Today I want to talk about lines. Lines are everywhere. Some lines are bent, but that means that they're no longer lines. They're different objects. But the simple lines that we see often in math are drawn on a Cartesian plane, which is named after Rene Descartes, who invented geometry. And that's why the Cartesian plane is named after him, because this is used a lot in geometry. For example, if you have 3 points on a coordinate plane like this, like let's draw a point here, and a point here, you can see that they form triangles. So you can do a lot of things with the Cartesian plane. Now, here's the thing. Can you find out the linear equation for this? And you're probably wondering, what? That looks like a pizza. What are you talking about? Well, these lines can actually be defined. So what I mean is that we shouldn't consider this for a moment. If you actually look at a line like this, you could see that it is composed of points, such as right there, and there, and there, and so on. And it has infinitely many points for reasons I won't discuss, but maybe in a future video it will. How many points are there in a line? I'll write that down, actually, because it's important. How many points are there in a line? And now we can describe this as 1, 1. Teachers may describe this as the domain and range of the point, but what they really mean is that domain is everything on the x and range is everything on the y, which may still leave you feeling confused. But just think of it like this. The domain is like you're on the internet and you put something in the domain. The domain is like google.com. And then the range, you get something out of it, like a web page that shows up what google.com is. It's a search bar. Or for example, let's take the domain to be msn.com. And when you put enter, the function, which is what the browser is doing internally, will give you something out of it called the range, which is really whatever is on msn.com at that time. That's really all that domain and range is. You put in a number and the function does something, and then you get some other number out of it. For example, here, let's put in number 4. The function will do something, and then you get number 4 out of it, because that's what the point is. Now, you're probably wondering, what is the function? Like, how is it giving me number 4? Well, if you look at the points, we're actually going to find out what the function is by investigating what the points are showing up as. Like, we're doing an experiment. We're putting in something, we're putting in numbers, and we're getting numbers out of it. And we got to find out what that function is. Well, so the function is composed of the domain and the range. So if you put in number 1, you get number 1. If you put in number 2, you get number 2. You put in number 3, you get number 3, and it's the same thing, so on. So we could say that y equals x. And really, that's the function. You put in some number here, and you'll get the same number back. So let's say that x equals 20, y will equal 20. You can verify that for yourself by continuing to draw the line, which I won't do here. But if we draw another line, this time in red, then you can see that the slope of the line is different. You ever been skiing? If you haven't, Well, if you have, then you'll know what I'm talking about when you want to go and ski on a mountain with an easy slope. That means something that is like very gentle, like this. This is like a really gentle slope. You don't want to do the black diamonds, which are something like this, unless you're experienced. This is what slope is on lines. Here we could see that the slope is more, the red slope is more than the black slope, but you can actually figure out the number for yourself. And by finding out what the slope is, you know more about the line. So for example, every time let's look at the black line. Every time we go to the right by 1, so and number 1, like let's do this. We'll actually write the numbers. 1, 1, 2, 2, 3, 3, and so on. Every time that we take 1 step to the right, this way, because that's what we did to x, we took 1 step to the right. Y went up by 1 as well, so the slope is 1. Let's look at the other line, this time in red, to denote that we're looking at the red line. So if we look at any 2 points like this one and this one, we get, just try to find the points, and you should get 1, 2, and 2, 4. Well, we went over 1 step and y changed by 2, so the slope is 2. And that makes sense. The slope is double the black line. It should definitely be more than the black line, and it is. The slope is 2 here. So we could write y, and actually you can see the pattern. For every 1, if you get number 1, you get 2 out of it, 2, 4. It's like you're multiplying by 2. So you could say that y equals 2 times x. Now let's say we have a different line. Like, let's say we actually have the same slope, but it's at a different place. So like something like this. Let's say it started over here now. It's the same exact line. You could tell, well, let me draw it very finely. There you go. You can see that the lines are parallel, and they should be parallel. They're like exactly spaced apart at all distances because the slope is the same. They're increasing at the same rate. So they're never gonna touch. It's clear. This time the points are different. So I'm actually gonna write over here. I'm gonna write it in green. This time we'll write, let's see, because I don't really like this. I'm gonna go ahead and cut it out. Perfect. And now in green, we'll put x, y. And now let's pick 2 points, such as this one and that one. So 1, 5, and the other one will be 2, 7. So they're the same slope, but how do we figure out what the function is? Well, there's an easy way. If you see that if you're going to the right by 1, you get 2. Let's go to x when it's 0. What is y? Well, 2, 7. Let's take a step backward. 1, 5, so it decreased by 2. Now we're going backwards. So that means at 0, this will decrease by 2 to get 3. So it starts at 3. So really, we could just write the line y equals 2x plus 3. And that's really it. for example, you plug in this value right here, 2. Plug in 2, you get 2 times 2 is 4 plus 3 is 7. That's accurate. That's really it. That's how you find slopes and intercepts to get slope-intercept form. And that's really all it is, dudes. If you want, you can do it another way, which really means y. Well, I'll write it in blue. This is the shortcut way. Now that you understand the concept, I can show you this. Teachers, please take note that you should understand and show the concepts to students before you show the formulas. So y2 minus y1 over x2 minus x1. Notice that these are the same points. This is the same point. It's the second point, and you just put in their x and y, and that's the first point. So let's go over here and consider these 2 points. The 2 points are, and I'll put them in green again, 1, 5, and then 2, 7. These are the 2 points. All right, so we said y. Let's see. Either point will work. Let's pick this one as our second point, okay? 2, 7. So the y of this is 7, and the x of that is 2. Now we subtract the first point from it. The y of that is 5. The x of that is 1. So you get 2 minus 1. I mean 2 over 1. And so that equals 2. So the slope is 2. That's literally what's over here. That's really all there is to slope-intercept form. I don't know how teachers can take hours just trying to teach this and have students so confused. It's really not that hard. But I do have compassion. Having to repeat the same creative ideas 4 times a day can take its toll. That's all that there is to it. So we found out how to do the functions. We found out the functions from the points. You can do this for any line. Even lines that go down, like, for example, lines like this. That line will keep going, obviously, but I don't have the time to draw it. It will take me ages and probably forever because lines are infinite, unless you define them to stop at a certain point. So over here, you can pick 2 points, such as that and that. An easy way to tell the slope is this. For every 3 steps you take to the right, it goes down by 2, so the slope is -2 over 3. But let's prove that mathematically. The points here are 1 and 1, well, 1 and -1. And the other point is 3, -3. Wait a minute. Sorry, it's not 1 and -1. It's 0 and -1 because right here, this is 0 and -1. I messed up, but that's correct now. Now, using the same technique to find the slope, we call it y. I'm not really sure what we call it y. It should be called m, right? We'll call it m. Yeah, we will call it m. So we get the second point, which is -3 and 3. Subtract the first point, -1. Of course, the negatives form a positive, and then 0. So you should get, obviously, you add these 2 numbers, -3 and 1, positive 1, you get -2, and 3 minus 0 is 3, just like I predicted, -2 over 3. So that's the slope. Now the y-intercept is just -1. So the formula is y equals -2 over 3x minus 1. That's right. Let's prove it. So some point like this. It says here that x is 6. So we'll put this 6 in here. 6 times -2 is -12. -12 divided by 3 is -4. -4 minus 1 is -5. The point should be 6, -5. Let's verify that for ourselves. And it is. That's it, dude. That's all I got to say about this video. Hope you enjoyed. Make sure to subscribe and come back for more math. Thank you.